गुड इवनिंग मैम।
गुड इवनिंग भावेश, आई एम वेरी प्राउड ऑफ यू।
गुड
वेल डन
इवनिंग
बच्चे,
मैम।
बहुत अच्छा स्कोर है। गुड इवनिंग बेटा, हाउ मच इज योर स्कोर सृजनी?
मैम,
247 and chemistry I've got 100.
अरे वाह, वेरी गुड।
Ma'am, thank you for that practice last day. It helped me.
या
I
मैम
also did
they
not
were the
expect.
same questions.
they were not the same, they were similar, they were not the same।
मैम some were same.
अरे ऐसे मत बोल भाई, मैंने खुद टेस्ट बनाया है दोनों। ऐसे कैसे? मैंने वर्कशीट भी मैंने उसी दिन बनाई और मैंने वो भी उसी दिन बनाया। ऐसे मत बोलो कि सेम थे, नहीं होंगे। दो तीन सेम हो सकते हैं, बिकॉज देखो, अगर इफ यू नोटिस ना, इफ यू रीच अ वेरी गुड प्रैक्टिस लेवल, ठीक है, अगर आप बहुत अच्छा एक प्रैक्टिस लेवल रीच कर जाते हो एक टॉपिक के अंदर, यू वुड रियलाइज मोर और लेस एक पॉइंट के बाद डिफिकल्ट क्वेश्चन बन ही नहीं सकते। सब तो एक ही तरीके के होंगे, ज्यादा से ज्यादा क्या मैटर कर जाएगा, क्या चेंज हो जाएगा? थोड़े ना कुछ वो ऑल्टर कर देंगे कुछ। So, अगर आप एक लेवल तक पहुंच जाते हो ना, उसके बाद क्वेश्चंस का डिफिकल्टी लेवल ऑलमोस्ट सेम होता है। और कोई क्वेश्चन होगा जो बहुत ही ऐसा लगेगा कि अरे वाह, ये तो बहुत ही अच्छा क्वेश्चन है, वो चीज अलग हो जाती है। बट मोस्टली सिमिलर ही होते हैं, आपको अलग नहीं दिखेगा। इवन अगर आप एन अवस्थी में पहला आपको लेवल 3 आपको बहुत डिफिकल्ट लगेगा, फर्स्ट 2 3 10 क्वेश्चन। वंस यू गेट द हिच ऑफ इट, ये क्या कर रहे हैं, तो उसके बाद आपको इजी लगना स्टार्ट हो जाएगा। यू विल नॉट फील कि वो डिफिकल्ट है। और हर देखना, हर टॉपिक के साथ केमिस्ट्री में तो खासकर यही है। मतलब जो स्ट्रैटेजी मैंने आपको फिजिकल के लिए बताई है वो ये है। ऑर्गेनिक के लिए स्ट्रैटेजी हल्की सी मैं बदल दूंगी, इनऑर्गेनिक के लिए बिल्कुल चेंज हो जाएगी। ऑर्गेनिक के लिए आई विल हैव अ डिफरेंट स्ट्रैटेजी। जब ऑर्गेनिक पढ़ेंगे ना, तो आप देखना उसके लिए एक अलग मैं बताऊंगी आपको अलग चीज। क्योंकि उसमें फिजिकल में क्या रहता है ना, न्यूमेरिकल्स हैं, एक एक टाइप के न्यूमेरिकल हो गए, थोड़े टफ टाइप के न्यूमेरिकल हो गए। ऑर्गेनिक में उल्टा है। फिजिकल में न्यूमेरिकल सीधा 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 सीधा, क्या चेंज हो जाएगा? फॉर्मूला तो चेंज होने वाला नहीं है। ऑर्गेनिक इज लाइक दिस, सडनली ऐसे आती है ऑर्गेनिक। बिकॉज हमने आपको टेंथ तक, मतलब वो जो, मतलब टेंथ में जो है ना, बच्चे आके मुझे बोलते हैं ट्वेल्थ में आप लोगों ने टेंथ में हमें बेवकूफ बनाया, कार्बन क्या पढ़ा रहे हो, आइसोमेरिज्म, कितना प्यारा प्यारा सब कुछ, और ये क्या है ट्वेल्थ क्लास केमिस्ट्री, इलेवंथ क्लास केमिस्ट्री, सडनली ऑर्गेनिक केमिस्ट्री चेंज। बट उसके लिए भी ट्रिक है, उसके लिए भी ट्रिक है, उसको भी कैसे करना है वो भी मैं बताऊंगी। अगर आप वो टिप्स एंड ट्रिक्स फॉलो करोगे ना, वो ऑर्गेनिक कभी आपको लगेगी बेस्ट फ्रेंड है आपका। और ऑर्गेनिक जिसको आ गई, उसका जेई क्लियर है, ये मैं बता दूं तुमको। क्योंकि ऑर्गेनिक में ही सबसे ज्यादा बच्चे रोते हैं। मैम सब कुछ पढ़ लिया, ऐसा लगता कुछ नहीं आता। ऐसे बच्चे हैं मेरे पास। मैम सब कुछ पढ़ लिया, लगता कुछ नहीं आता। कैसे नहीं आता? क्योंकि उसका एक्सपेंस, इट्स लाइक अ वाइड सी, यू लुक एट अ रिवर, फिजिकल केमिस्ट्री इज अ लार्ज रिवर, ऑर्गेनिक केमिस्ट्री इज लाइक सी, ब्रह्मपुत्र मीटिंग द सी, दैट्स ऑर्गेनिक। तो उसको करने के लिए भी टेक्निक होती है। पीपल क्रॉस द ओशंस ना, तो
But
उसके उसको
organic
करने
is
के लिए भी तरीका है, वो भी हो जाए।
more interesting than inorganic.
वो सब चेंज होने वाला है भावेश। कह रहा ऑर्गेनिक इज मोर इंटरेस्टिंग। आ रहा है इंटरेस्टिंग क्वेश्चन आ रहा है। इनऑर्गेनिक भी बहुत इंटरेस्टिंग है, बट इनऑर्गेनिक पढ़ाने का एक तरीका होता है। क्योंकि इफ आई जस्ट से कि इनऑर्गेनिक इज जस्ट रटा, जस्ट इसको रट लो, वो फिर आपको मेरे से भी हेट हो जाएगी और सब्जेक्ट से तो हिट हेट होनी ही होनी। ये क्या मैम ने ये बोल दिया, जस्ट आप ऐसे वो रट्टा मार लो, ऐसे नहीं होता है। बिफोर आई टेल यू कि रट्टा मारना है, आई वुड टेल यू कि रट्टा मारना कैसे है। खाली है क्या, चार चीजें ऐसे कर लिया आपने, इसका रट्टा मार लो, 4 दिन 5 दिन रिटेन रहेगा। किसी का बहुत अच्छी फोटोग्राफिक मेमोरी है, उसको 6 महीने रिटेन रहेगा, एक दिन तो भूलना ही है। तो इसीलिए उसको करने का भी एक अलग तरीका है। बट आई टेल यू ऑल द थिंग्स, I'll tell you the way in the way my teacher used to tell. I told you na, Dr. Shanti Keswan. I told you about her. The way she used to tell. To this day, I have taught coordination at college level also. मैंने आज तक सिवाय 2 टॉपिक्स के अलावा मैंने कभी किताब उठाई नहीं है। वो सब कुछ यहाँ भरा हुआ है, इट्स हियर। वो कोई लेके ही नहीं जा सकता, बिकॉज इधर है ना। इधर आ गया तो किधर जाएगा? अगर सिर्फ यहाँ तक रहेगा ना, तो भूल जाएगा। एक बार यहाँ चला गया ना, तो नहीं भूलेगा। यही खासियत है केमिस्ट्री की, और वो बहुत वॉलेटाइल है, इसलिए आपको लॉक करना पड़ेगा। ऑर्गेनिक केमिस्ट्री, इनऑर्गेनिक केमिस्ट्री और वॉलेटाइल सब्जेक्ट्स, फॉर्मूलाज तो आप कर लोगे, ये फॉर्मूला आपको याद रहेंगे बहुत दिनों तक, क्योंकि अब इतना बार कर चुके हैं। ऑर्गेनिक इनऑर्गेनिक ऐसा है, अगर खुला रह गया ना, तो उड़ जाएगा। इट्स जस्ट लाइक एसीटोन। आपको याद करके उसको लॉक करना पड़ेगा। हाउ यू हैव टू लॉक, दैट्स द ट्रिक। आई विल टेल यू द ट्रिक। आपको जहां देखोगे ना, आपको सिर्फ फॉर्मूला शीट याद आएगी। एंड वन ऑफ माय स्टूडेंट्स, आई रिमेम्बर, जस्ट 2 months ago, शी वाज हैविंग सम टेस्ट सीरीज इन स्कूल। कुछ उसका इंटीग्रेटेड प्रोग्राम है, तो उसका वहां टेस्ट सीरीज है। शी सेड, मैम बहुत प्रॉब्लम हो रही है, आई डू नॉट नो हाउ टू डू दिस। ऐसे प्रॉब्लम सारी सॉल्व हो जाएगी, just do it the way I am doing. Now she has a 4 a.m. club with her 4 of her friends. They all wake each other up at 4 a.m. They start studying by 4:30. They are following the same technique. All are my students only. They are following the same technique. And their room, now their parents are like, when I enter into the room, वो जो एक UPSC preparation वालों का देखा है, ये room कैसे होता है? All those chits and all. Their room is filled with that. So there is a way to do things. It's not, see, you know, when somebody can get full marks, it's not something which is not crackable, right? It's achievable, na? It's achievable. So if it is achievable, then there should be a trick to achieve it. अभी hard work तो सारे ही कर रहे हैं. So if we take a population of, let's say, 3 lakh students are appearing for IIT JEE. Don't be scared by 3 lakh. उस 3 lakh में से, let me tell you, 60,000 या 75,000 है जो एक्चुअली पढ़ के जा रहे हैं। ये भी मैं ज्यादा बोल रही हूँ, बाकियों को पता ही नहीं है पढ़ते कैसे। रेस्ट ऑफ द स्टूडेंट, दे जस्ट आर स्टडीइंग विदाउट एनी पर्टिकुलर एम। some people come to me and they say, ma'am, we love chemistry. I said, please don't love chemistry, please. We love physics, don't love physics. We love maths, don't love maths. The thing is कि you have to do all the subjects to go and reach your goal. If you want to love a subject, then do PhD in it, like I did. मैंने किया क्योंकि मुझे केमिस्ट्री पसंद थी डे 1 से, इसलिए मैंने किया। आई डिड ऑनर्स। किसी सब्जेक्ट में ऑनर्स करना इज समथिंग व्हेन यू लव अ सब्जेक्ट। अभी के लिए अभी कोई लव हेट की जरूरत, लव इज अ वेरी स्ट्रॉन्ग इमोशन। नो लव नो हेट ओवर हियर। यू जस्ट हैव टू डू अ सब्जेक्ट टू रीच योर गोल, बस। when you reach IIT, then you might love mechanical engineering or AI or whatever, robots, जो भी आपको करना आप करो करो, फिर देखेंगे कि what is love, then love will change the definition. See, that is what we want from you. अभी तो ये सब is like एक वो somebody said कि I love chemistry the most, उसमें उसी ने मुझे धोखा दे दिया। है धोखा दे दिया? I got 93.4%। धोखा दे दिया क्या है? सही तरीके से पढ़ो, नंबर आएंगे। The day one I told, stop saying chemistry ने धोखा दिया। केमिस्ट्री क्यों धोखा देगी तुमको? तुमने ठीक से नहीं पढ़ा। You don't know the tips and tricks. Then that same guy got 99.9 in chemistry second attempt. उल्टा second attempt का paper was more difficult. It was more difficult, but he got. That's when you change the perspective at a subject. So within 2 months, nothing can change, but he changed. He changed everything. How he was doing the questions, he started timing himself. I said, beta, if it's 20 minutes, it has to be 20 minutes. So that day, that is why I was saying again and again, Srijani and Bhavesh, वो 20 minutes वाला जो target था ना, वो achieve करना था. And see, the result is in front of you. The result is in front of you. So the trick works, right? So the method works. So that is what I've been saying since day one. ये methods proven है, ये आज नहीं बनाए, बहुत पहले से बनाए हुए हैं. ये मेथड्स प्रूवन है। हमारे बच्चे जब क्वालिफाई करते तो ये मेथड्स प्रूव किए हुए हैं। सो इफ यू वांट, यू हैव टू गो, यू हैव टू वॉक ऑन दैट पाथ, एंड आई एम श्योर इट्स नॉट इजी। समटाइम्स you have to like give up so many things that others might be doing. Somebody is doing something, they are going out for party, you are not going, 4 questions are left, they are important to you, वो करके जाना है, तब तक वो चीज खत्म हो। You have to give that much amount of sacrifice, बेटा। That is there, वो करना पड़ेगा। Otherwise, at the age of 22, 23, who will give you 1 crore का पैकेज? 1 crore a year, पता है कितना होता है? क्या 1 crore में कितने जीरो होते हैं? 9 के कितने? 7 कितने होते हैं? 7 होते हैं। 7 होते हैं ना? है ना जॉयनील? 7 होते हैं ना?
Ma'am, don't ask me. I don't work in crores because I live internationally. I'm too used to the international system.
Oh Oh my God, he's like in millions, like,
Yeah,
पर
10
9
million.
होंगे कि 8
10 million. Yeah, I think we all know how many 10 million has.
So, so Indians know everything. These people, when they go to UAE, they forget the crores. They forget the crores and the lakhs. We know everything. Dollar, dirham, everything we know, right? These people forget. So yeah, we have to do the things in that manner. Imagine a 25-year-old driving a Tesla. है भावेश, तैयार हो जा. बस अभी अगले 9 साल में तेरे को टेस्ला लेनी.
Ma'am, I don't like Tesla.
You don't like Tesla? It is so good. What is this? They were saying when Tesla is in India, now what will happen? Somebody will come to clean the car. Somebody is begging. There was this meme. So suddenly the window, it rolls down. There's nobody inside. The beggar gets scared. Who is driving the car? So, but it's a pretty neat car, by the way. It's a pretty neat car. Favorite car कौन सी है? Bugatti.
It is not a neat car. Agree to disagree. Its
I'm like,
specs
it is
are
only at the end EV.
horrible.
Choices are subjective. Choices are subjective. For me, Balenciaga bag is like very good, yaar. Get me a good bag, I'm very happy. Get me matching shoes, I'm so happy.
Louis Vuitton, ma'am. Shoes.
हाँ क्या?
Louis Vuitton shoes.
ना लुई विटॉन के नहीं चाहिए. और बड़ी ब्रांड्स हैं. बहुत सारी ब्रांड्स हैं, don't worry. For someone who has mauve colored shoes, you can't argue. I have a good collection of shoes. I love shoes and bags. More shoes. matlab, mostly it's like if I have a very light pink dress, I have light pink and dark pink shoes both. So yeah, to each their own. Yeah. So there are two shades of black also, right? One is the lighter gray shade, the other is the darker black shade. Yeah, it's okay. You can curse me all you want, but I am like that. I like a good pair of shoes. And I like a good perfume. Yeah. So yeah. So everybody has. I think as a Punjabi, I have good rich tastes. Right? Just like all Punjabis do. Srijani will definitely disagree. Bengalis are they have richer taste in food, Yeah. They say food, we want food better. But yes.
Yes, ma'am, biryani.
Sorry, what?
Yes, ma'am, mutton biryani. I have a special taste for that.
Finally, someone who
Oh,
actually likes mutton biryani over chicken biryani. Genuinely.
see,
Yes,
biryani
ma'am.
any day biryani. You wake me up at 2 a.m. I'll have biryani. It's okay. Biryani is all-time favorite. Any biryani, chicken, mutton, not prawn. I don't like prawn biryani. No.
Ma'am, more than
Okay.
chicken, it is mutton.
What? Sorry?
And more than chicken, the most tasty is mutton.
Yeah. Mutton is better. Any day better. Yes, it is better. Okay. We had discussed Heisenberg's uncertainty principle, and I had shown you that video. We had done some questions also, right? And now we are going to discuss Schrodinger wave equation. Did we do any discussion on Schrodinger, by the way? No, right? So, Erwin Schrodinger was having a snack in his canteen, in his college canteen, where he used to do in his lab near his laboratory. He was having a snack when he thought of this wave equation, and he actually, it is a legend goes that he wrote it on a tissue paper. The very basic, he wrote it on a tissue paper. Yeah, that's how it began. Yeah. So later on, he did all those things, and he detailed it. What are complex numbers, if I may ask? Anybody?
Any number
They will
represented
represent it by x plus
Number
iy, having
a
a real
combination
part
of a
and an
real number and
imaginary
an
part.
imaginary number make a complex number.
Has a real component and it has an imaginary component, right?
Yes, ma'am.
Now, Schrodinger said, since electron is a wave, there must be a function to represent that wave, right? And that wave is represented by a function like this, which is known as psi. PSI, P is silent, a Greek symbol psi. It's a function which represents a particular wave. You can hear me out. You can then I'll give you time to write. Now he said, just like there is a complex number in mathematics, right, which is represented by this form, psi is also like a complex number, which can be represented like this. Now psi is a function which represents the electron being a wave. Now the thing is, if electron is a wave and electron exists, I mean, it is for real, right? It's not an imaginary thing. It is existing for real. Now, Schrodinger said when you solve using, like when there is a number and you put various operators on it, you get different results, right? If I square a number, it's a different result. If I divide a number with something, division is a operator, multiplication, addition, subtraction, you will get different results. So Schrodinger said when you put different operators on psi, you will get various answers to the wave equation, right? And that's how we can find the energy and all those things related to an electron, all the factors related to an electron. But that's when Max Born chipped in and he said, you cannot have an imaginary component associated with a real thing. Can you? You can't have it, right? You cannot have an imaginary component for a real object, a real thing which is existing in nature. So now there was a controversy what to do. You can't have psi alone working, right? You got to have something else. Now that something else was solved. He said, when you square things, when you put psi square, when you have psi square, that will solve the matters. Because if you square a number, obviously that's going to be positive. If you square a negative number also, the result is going to be positive, isn't it? So
Yes.
he said,
Yes.
what you do is, the best thing is you square it. You square wave function. You square the wave function. Now, what does this psi square term represent? This represents probability of finding the electron in the 3D region around the nucleus. This is the probability. Okay, now that makes it so that makes more sense, right? Now it is the probability. Now, what is the first difference that you see here, beta, as compared to the Bohr model? Can someone tell me here?
Ma'am, in Bohr, he had fixed the position of the electrons, but here we are saying probability means it's not fixed or taken for granted that electron will be in this particular position, but there is a chance of getting the electron.
Yes. So probability is a chance factor. There is a chance of getting an electron at a particular place. It's not that it is going to be there, right? It's just a probability. Just like we have already proven from the hypothesis of de Broglie and Heisenberg's uncertainty principle that you cannot know from certainty from where the position is, because if you have certainty in position, you will lose the velocity and vice versa. Correct? So you can't have that. So you can only have a probability of existence of a particular particle. Understood, beta? This is clear to all of you. Those people who have not written may write it now. If this much is clear, please write it.
Ma'am, but if psi is a complex number, then psi square is not necessarily a real positive number. So how does it still represent probability?
See, I'm just saying, it's not necessary. I'm not saying it is just like a complex number. The negative part of the complex number, when squared, will give you a positive number. That's what I implied. Okay, got it. Written, beta? This is written.
Yes.
Yes.
Written. Can I go ahead, please?
Yes, ma'am.
Now there are various operators on wave function that can be applied and you will get the necessary information out of a wave function, right? For example, one of the operators is Hamiltonian operator, right? When we apply Hamiltonian operator on a particular wave function of associated with a particular electron, we get the energy associated with that electron. Once you get the energy associated with that electron, you are going to know most of the things, right? Energy will tell you the orbit in which it is, right? Right? Energy will also tell you exactly how much energy will it requires to be, taken out, that electron out of the orbit. Energy will also tell you how many electrons are actually placed in that particular orbit, isn't it? So once you know the energy, you know many things, right? So this Hamiltonian operator tells you the energy when you operate it with this. There are many kinds of operators which can be applied to wave functions to obtain certain results. Now, apart from Hamiltonian, there is a operator. There is an equation called Schrodinger wave equation. Schrodinger wave equation. I'm just going to tell you the form of it, beta. These are double differentials of psi with respect to x square, y square, and z square. There is no need to solve it. There are people going around and saying you can solve it. This is the derivation. It is strictly not in your course. We teach it in the final year of this college. There is no need to remember it.
Ma'am, is it 2 square 5?
Sorry.
Ma'am, is it 2 square psi?
No, del 2 psi, that's a double differential. When you
Okay, ma'am.
differentiate it once, then you again differentiate. It is a double differential with y square. Okay. Here it is del 2 del y square. Okay.
Ma'am, what is the fourth term that you wrote?
8 pi square m divided by h square. H is the Planck's constant. Okay. This is the total energy minus the potential energy because it is attractive that you have to subtract it. Then psi is equal to 0. Okay, beta? I can see many cameras are off today. Don't know why they are off. Grishma, no, somebody messaged me. Maybe Himanshu.
Ma'am, it's kind of raining here. That's why I switched off my camera.
Ma'am, the D's are the partial derivative sign, right?
Yes, that is partial derivatives. Yes.
H is Planck's constant here.
Yeah, Planck's constant, yes. Konika, why isn't your camera off? So the axes are also mentioned here, x, y, and z axes, right? Now you do not have to derive it. The solutions of this equation are presented to you. Okay. These solutions are called quantum numbers. These solutions are called quantum numbers. And they are the ones which will give you all the details of this particular associated with this thing. Okay.
Excuse me, ma'am.
Yes, beta.
Ma'am, the solutions we get by using this equation that we call quantum numbers.
Yes, beta. Yes, yes, absolutely. Now let us look at various quantum numbers. Okay. The first quantum number is n, principal quantum number. Principal, the spelling is that of school principal or college principal, principal quantum number, not PLE, PAL. Okay, got it? Okay, now let us look at the meaning of this. What does N tell you about? N tells you about the energy associated with a particular orbit, right? Now we all know when energy has to be associated outside the nucleus in a probable region where there's probability of the electron existing. Do you think the energy can be zero? No. It has to be finite, right? So the permissible values of n are 1, 2, 3, all such things, infinity. As many elements we know, we will keep on, increasing the number of this. Okay. The second solution to Schrodinger wave equation is represented by the letter small l. Small l. It is called the azimuthal quantum number. It is called the azimuthal quantum number. Okay. What is this associated with? It is associated with the this shape of the orbital associated with a particular value of n. Now, instead of like orbits, like you can understand it like this. Remember how in the Bohr's model, when you studied K, L, M, N shells, you had you said that although the maximum number of electrons that can be filled in the third shell are 18, but you have to tip off at 8. Remember? So
Yes.
this azimuthal quantum number digs in a bit deeper and it tells you there are places within a particular n value where electrons can be there. The probability of existence is there, and they're definitely not circular. They're not spherical. Like you said, orbits are spherical. Now imagine, I told you that day also, imagine the nucleus like the axle of a wheel. You know, inside there is a metal part around which the wheel is there, and the wheel to be the first shell. Now you go on increasing the shells. That means you put on another shell, another tire, and the radius is increasing. Imagine the 80th electron. Where will it go? So now this quantum number tells us not all of the places inside a particular n value have to be spherical. They can be of different shapes. Okay. They can be of different shapes, so that there is maximum stability and minimum repulsion. Okay. So the L values are associated with that. So how many L values a particular n value can take? 0 to n minus 1. These are the permissible values. Okay, these are the permissible values. I'm also telling you the permissible values. We'll draw another table where I'll just have the values. But for now, please appreciate this thing. Okay. I have seen lot of YouTube videos also where they are going around saying there are 4 solutions to Schrodinger wave equation, which is completely wrong. The direct solutions are 3. The 4th is an offshoot. It's not a direct solution. So if any time the question comes, how many direct solutions to Schrodinger wave equation are there? Please write 3. N, L, I'm going to the next one, which is the M. Or as we call it, M subscript L. Magnetic quantum number or angular momentum quantum number. What does it signify? What does it tell you? It tells you about axis orientation of a particular value of L. Axis orientation. That means if I said that the shape is not spherical, it has to be something else. And if it is anything else apart from spherical, you must know which axis it is existing in, X, Y, or Z. Correct? All right. Understood or not?
Yes.
Is this going great till now?
Excuse me.
Everybody is
Yes.
understanding. Hanji beta, hanji, bolo.
Ma'am, what are structures?
I'm coming to that. रुक जाओ. बता रही हूँ. आज मैंने कोनिका को पहली बार देखा है. First time. Never seen you before. You should turn on your camera, right? Grishma, I don't know. I think she messaged me once. I don't know. No. And Bhavya Deep.
So I currently cannot switch on my camera.
Okay. So these are the 3 direct solutions of Schrodinger wave equation. Okay. These are the 3 direct. Now there's another value which is associated, which is also called the 4th quantum number, which is not the direct solution, but I will come to it a little while later. Let us now draw the table. Okay. Oh, let me tell you the permissible values of ML. Sorry. Forgot that. The total values, the maximum values that can be obtained are 2L plus 1. Please understand, these are the maximum values. Okay. And the values that a particular this L value can obtain are minus L2 plus L. Maximum values are 2L plus 1. So you know where to start and where to end. So all the numbers on the number line from minus L2 plus L would follow. Okay. Not the decimals. Okay, fine. Let's do this. Let's start making the table. Draw a neat table. First value is n is equal to 1. 0 to n minus 1, 1 minus 1 is 0, 0. So a की value होगी 0, right? 2l plus 1, 2 into 0 plus 1, it will have only one value again, which is what? 0. There's nothing minus 0 to plus 0, yeah, it is 0 only. Okay. N minus 1 you can write down over here. 1 to infinity. Let's write 2. So as I said, 0 to n minus 1. So it is 0 and 1. Now we know the value which is associated with this 0. 2l plus 1, 2 into 1 plus 1 is 3. And minus L to L would be?
Minus
Minus
1,
L to plus
0,
L would be? Minus
1.
1, 0 and plus 1. Let us just stop till here and see what's going on over here. Now, 1 is associated with the main value, main full orbit which we knew, like KLMN shells, remember? Right? Now, 1 when it is associated with azimuthal quantum number of 0, it means it is a spherical orbital. Spherical orbital, which is inside the main value of main shell, which is 1, which is the value with which it is associated with 1. This is known as s orbital. So 0 number, the 0 solution indicates it's associated with a spherical s orbital. It's called s orbital. Okay. Now 0, it means spherical. It clearly means once it's a sphere, it is equally associated in all the directions, correct? It is equally associated x, y, z. So that is why, the angular component you can see here, it's 0. So again, this is s orbital. Along with this, the value of L when it is 1, that is P. P is dumbbell shape. You know those dumbbell which those people, gym goers, they pick up. Dumbbell shape. Roughly like this. I'm going to show you a beautiful video on the shapes of these orbitals. You're going to enjoy it so much more. Okay. So when I say it is a dumbbell shape, I have to know in which direction it is, It's not like the spherical one. It is equal in all the directions. It's going to be Px, Py, Pz. Any value here can be associated with Px, Py, Pz, but it's just I'm so good in ABCD, so I just write X, Y, Z in the same order, okay? It could be anything. आप Y, X, Z लिख लो, आप Z, Y, X लिख लो. It could be any permutation combination. So don't say कि only minus 1 belongs to this. It's just a number. You can just associate it with any direction, okay? Fine. Let's go to the next number. In the next class, I'm already telling you, I'll tell each one of you to draw the entire table. Okay? Everybody will draw it. First thing you come, you know what to do. You are drawing the table. Okay? 3. Now, these are the subshells. This one, Bhavesh. Inko subshell bolte. These are the subshells which are occurring inside a particular value of L. Now, you can understand that obviously it is so difficult. You can understand it's so difficult to just imagine spherical orbits. So there are orbitals inside which are just not spherical, but other shapes also. So it is just not, this theory is also telling you that just a spherical shape would make it so energetically unstable to occupy all the electrons in that one sphere only. And then you think of 118 or 80 atomic number. Keep on filling in. Though last electron is not even able to see the nucleus. Come on, how are you even trying to explain that atom is stable? It's not possible. So you have to give a proper explanation, right? This theory is very well doing it. So 0, 1 and 2. N minus 1 will be 2. S and P we already know. Now the third orbital is there, which is associated with N is equal to 3, which is doubled up. So 0, minus 1, 0, plus 1, minus 2, minus 1, 0, plus 1, plus 2. Okay, 2L plus 1, 5 values maximum. Minus L to plus L would be this. -2, -1, 0, +1, +2. Now, what are these values associated with? Again, in no particular order. dxy, dyz, dxz, dx square minus y square, and dz square. Okay? These are what the 5 numbers indicate in no particular order. Again and again, I'm trying to say. I will show you the way they exist in a video. Just hold on. Just keep on noting down. 0, 1, 2, and 3, and -1, S, P, D, and F. And spherical. Now, they say this is diffused, but in the video, you'll see it is not diffused. There are values associated with it, and the shapes are complex. So that is why at your level, we keep on saying it is diffused, not diffused. But there are shapes associated with this. So 0, -1, 0, +1. -2, -1, 0, +1, and +2. Again, how many values associated here? 7. -3, -2, -1, 0, +1, +2, and +3. Correct? So 7 values are associated over here. F orbital. So there are SPDF. Here till you finish your 118th element electronic configuration, you will realize these much are enough for you. There are other orbitals also like G orbital. After that, if you find more elements, the G will start to fill. Okay, but till now we have found out 118. For that, you will soon know how to fill up for any particular atomic number, how to fill up according to this. There are 4 rules which are associated with this. You have to learn them, right? And then we will see how to fill up the individual orbitals. Now, first rule I will tell you. Please note it down very correctly. Each ml value can have maximum filling of 2 electrons. Okay, maximum filling of 2 electrons. Let's just now calculate. You will be surprised, happily surprised. 2 electrons here maximum, right? Here 2, 2, 2, 2, 6. Total is 8 with one value of n. Correct now? With value of 2. So 6. Has everybody understood how this 8 came? Each value of ml is associated with maximum filling of 2 electrons. So 2 here, 2, 2, 6, 6, and this will have 2, 8, total of 8. 2 plus 6 here. How many here? 2 5s are 10. See where we are going again. Old is gold, my friends. Old is gold. See where we are going? We're going to Bohar uncle again. And now we are going to Bohar uncle again. 14, 2 7s are 14, 32. That means he just could not explain the difference between spherical and the other orbitals. He could not find orbitals. Maybe it was all the time there. Yeah? You get my point? So this is how the magic is woven over here. So this theory actually just is a little bit more flexible for the introduction of shapes. And you know how these shapes have been traced with good techniques. I'll tell you how. If you have seen that, does anybody know what a seismograph is? Seismograph is an instrument which detects the intensity of earthquakes, right? If you've seen the epicenter, near the epicenter, it's like this, the lines are very huge and then it keeps on fading out. So that's how the scientist knows this is the epicenter. And if you've seen it, they'll tell you the exact epicenter also. Like, is ghar ke niche, ya is pahad ke niche earthquake ka epicenter tha, from where the tectonic plates started rubbing, and that's how the earthquake came. Here also, what we do is the instrument traces the path of the electron at a certain energy level outside the nucleus. The instrument traces the path. So it's not like dumbbell हमारे दिमाग में आ गया, नहीं, ऐसा कुछ नहीं. traces the path, कि exact path किधर था, outside the nucleus, and that's how they knew. So science is always supported with better sophisticated instruments, right? And mathematical calculations, of course, right? That help. And Bohr, I mean, he was, obviously he probably did, he could not support it with better mathematical calculations or with, better sophisticated techniques. So he stayed there, but, it's ultimately it's coming out to be this only. Yeah. All he was missing out is a certain more calculation, certain more tweaking into his theory, and a certain more, like what you call more flexibility, I would say. Yeah. So it's just a matter of few more years, few more people came, and then that's how they got along to think about this. So I hope you're able to appreciate what quantum numbers are now. 3 of them are there. 4th is yet to come. But have you understood this?
Yes, ma'am.
Are you ready to see that video?
Yes, ma'am.
I'll just show you that video. Anybody having any doubt here, please let me know. I would
Ma'am,
be
I just
happy to
wanted to
cater.
ask that यहाँ पे we got the number 32. Does that mean that when n is equal to 3, then there are 32 electrons in that
When
shell?
n is equal to 4, beta. When
Oh,
n is
sorry.
equal to 4, not 3. Yeah. Yeah, of course. Of course.
So here n represents the shell, right?
Yeah. Principal quantum number is the same which you've been carrying out since that, that बोहर का model. Same beta. n की value हम डाल रहे थे ना वहां पे.
Yeah. Okay.
Same only, same. One second. Just give me. Yeah. Okay. Let's have a look. You can all see.
Yes, ma'am.
On the top right hand and the left hand, they will keep on showing which orbitals they are referring to. Look at the entire screen. Don't concentrate anywhere else. See, 0.529 angstrom, same radius, yes, as that we calculated in Bohr's, right? So roughly same. Full attention on the video. Now they will show you each and every single orbital, and they'll show you how the shapes are altering. See this now? Isn't it just like the seismograph? Yes?
Yes, ma'am.
Yes? Can you
Yes, ma'am.
appreciate this, everyone?
Yes, ma'am. Yes, ma'am.
Look very closely, beta. See how it is symmetrical in all the 3 axes? The value of 0. See? It's written at the top, this left-hand side also. Can you see there's a table which they are drawing, and the top right-hand side, they're showing the orbital. See? 1s idhar likha hai, idhar NL, this table is drawn, the one which we drew just now, huh? देखो बेटा, ध्यान से देखो. Concentrate fully. With n is equal to 2 now, okay? Now they are just this, crunch it down a little bit for you to imagine better, huh? See? See? 2s. See how beautifully they've shown it different colors. See, just outside, just a small space is there, then they're encountering 2s. Now they are only focusing on 2s. See now. Now radial node, 1 second. So this is a place in between two orbitals where there is no probability of finding an electron. We'll do questions on nodes also. I'll tell you the graphs, how to draw the graphs of node also, okay? Okay, I'll tell you. Watch carefully, beta. Nodes we are going to take up, don't worry. Look at the p orbital. See, px. It's in the x axis. Can you see how it is dumbbell on either side? The orbitals are there. The electrons are there. Huh? See nicely. Px, py, pz. See. See now in z direction. That is why values associated with every single ml value. Huh? So now see. They are showing all of the things together. Now n is equal to 3. Concentrate on the shapes of D now. 3s is spherical as usual. So inside you already know now 1s, 2s, 2p are buried. Now 3s. Now you're filling more and more orbitals. Now inside already there is 1s, 2s, 2p beta. Now 3s. Then 3p. Then 3d. Huh? Like that. See now. This px, 3px. Three py. Now 3pz. Watch carefully now. D is coming. The pz they're showing. After this p and d orbital will be there. Now you have to just note one thing when D comes. Wait. Look at this. This is dxy. Can you see it is in between the axes? It is not on the axis. So 3 dx, dy, dz. It is in between the axis. It is not on the axis. Watch very carefully. See? See. Dekha? It is in between the axis, not on the axis, bache.
Why is D
Should I go back?
Yes,
Now
ma'am.
see. Now it is in between the axis. The electron density is in between the two axes, not on the axis. Px, py, pz was on the axis, beta. Huh? You can note this down. That's why I didn't draw it over there. It is even drawn in the NCERT. You can open your NCERT in front of you and then you can, sort of correlate. Yeah, I would highly recommend that. In dy, dz, the electron density is in between the axes, not on the axes. Px, py, pz, it is on the axis. Questions have been asked on this also. Okay.
Why is it in between for the D?
Dx, dxy, dxz, xy, xz, and yeah, dxy, dyz, dxz. Yeah. Dxy, dyz, dxz. Okay. Should I move the video? Now see, they are going to show another one. dzx. See? अभी दिख रहा है? In between है ना? On the axis नहीं है ना?
Yes, ma'am.
Now see, dx square minus y square. It is on the axis. Can you see? It is on the axis. See, dz square is very cool because it is on the axis and there is a ring of electron density in the plane. There is a ring of electron density. See? Ring of electron density like that. I just want you to see the d orbitals once again. See, this is xy. xz. Now yz. ठीक है? Okay. Now x square minus y square on the axis. I hope you can appreciate this one. dz square, very cool, above and below, and there is a plane of like this on the plane. There is like there's a plate of electron density, you can say, right? Now you have f orbitals, as I called it diffuse. You'll see why I called it diffuse. See, this shape you're not supposed to know at your level, but still I wanted to show you so that, you know, if you see any video other, you're not coming here, you don't know, you told us it is diffused. It is diffused because it is all around. See this. See, there are 7 orbitals, each like this. On the axis and in between the axis, both. See this? Now this is in between the axis also. Yes? I compared it with a seismograph for a reason. Okay, I don't want to see this. We don't want to buy L'Oreal, right? So this is the, I hope you are able to appreciate, you know, what orbitals are and what are their shapes, how they are in between the axis, on the axis. That's the reason why I told you to open up the NCERT only while watching the video, because what happens is that when you see it in 2D versus when you see it in 3D, there's so much of difference. You can appreciate it like 10x better, right? So I'll post the link of this video also here on your WhatsApp channel, right? WhatsApp this group of yours, Vijeta 27. So I'll do that. If you want to rewatch it, you go ahead, you watch it, not a problem. But this is one of the best videos I have that is there, you know. A lot of videos are there also, but this is one of the best that I found, right? So I'll tell you to make this table again in tomorrow's class. You go through, you read this theory from NCERT. If there's anything which is troubling you in the text of NCERT, do not go and read from anywhere else. This much of information is enough. This table you should know. You are good to go. Now you should start doing questions after this. After I teach you the 4 principles tomorrow, I think, yeah, 4 we'll be able to do tomorrow. Then we start filling up the electrons. So by the end of this week, by Thursday's class, you'll be very well able to, you know, find out the electronic configuration, write down the electronic configuration according to Schrodinger wave model of the first 30 elements very आराम से. बहुत ही अच्छे से आप कर लोगे. But do things on a daily basis. Don't leave the things at all. I'll do it tomorrow. No. Okay? So I expect you all to know the things by by tomorrow's class, right? If there is any problem in understanding, do ask again in tomorrow's class. Tell me I have not understood this very openly. No problem. I'll just either take it up tomorrow. If not possible, then we'll take it up on Saturday again. Not a problem. Okay? चलिए. ये तो cream नहीं है. All right, guys, on the count of 3, 2, 1, let's go. 3, 2, 1. Amazing. Wonderful, you guys. I'll see you in tomorrow's class. Yeah.
Thank you, ma'am.
Okay then.
Thank you, ma'am.
Bye, guys. Thank you so much. Bye bye.